Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Soorya, your chemistry faculty from Infinity Learn. Hi Hafsa and Arush, good evening. Welcome to the session. I hope I'm audible. Okay, fine. So we'll be going to discuss the previous year questions of the chapter Acid, Bases and Salts. We have already completed the one-shot revision of the complete chapter. So, okay, thanks for the confirmation, Hafsa. So can we start our session? Let's directly move to our questions. We have already completed many times revision about the same chapter. We have already studied the physical and chemical properties of the acids, bases. Then we have already studied about the salts, right? So we can start from our first question. Read the question carefully. So here is the question which is asked in terms of CBSE 2023. So here is the question. Out of the following, which compound or compounds will turn the phenolphthalein solution pink? So this question is based on the indicators, right? Okay, fine. So options are provided here. First one is the acetic acid, second one hydrochloric acid, third one is nitric acid, and last one is the sodium hydroxide. Okay, what will be the answer? Yes, option D will be the answer, right? So option D will be the correct answer. So what is the role of phenolphthalein? As we all know, these are the indicators, right? So if I'm asking about the case of acidic solution, what is the color of phenolphthalein indicator? So while solving this question, we are going to revise the complete chapter. So what is the color of phenolphthalein in the acidic solution, whether it is pink color or colorless? So please give me the answers in comments. Yes, it is colorless, right? So in the case of acidic solution, they are colorless. Then what about the case of basic? It will be pink color, right? So we need to identify which of the following will be a base here. So here it is pink color. So as we already know, all the three options, like this is acetic acid, this is hydrochloric acid, this is nitric acid, which means all the three options are acidic here. So they will be colorless. Phenolphthalein will be giving colorless in the particular three solutions. But only NaOH, sodium hydroxide, is act as the base here. So it will give pink color with the phenolphthalein. Clear? Can we move to the next question? Here is our second question. Again, the question is repeated in the 2023. An aqueous solution turns blue litmus red. Which of the following solution added when excess in order to reverse the change? Read the question carefully. First word is given here. An aqueous solution turns blue litmus red. So as we already know, as an indicator, litmus paper is also used there, right? So here, if you are adding any of this given solution in excess in order to reverse the change, which means that we need to reverse the change, means red litmus will be changes to blue. So what will be the answer? Yes, option C is the correct answer, right? So here we need to check here. If I am taking blue litmus paper, blue to red means it is the acidic solution, right? Now, if it is changes red litmus to blue color, it will be obviously basic solution, right? Basic solution or base. So again, if you are comparing the options given here, lemon juice is containing, what is the acid present in the case of lemon juice? Hafsa, there is a correction in your answer. Vinegar means there is a acetic acid, right? So if you are containing acid solution, the change will be happening there. It is blue litmus to red. But our question is we need to reverse the change, right? First one, it is blue litmus turns to red. But the reverse the change means red litmus to blue, right? Red litmus to blue. So we need to get the answer as any one of is the basic solution. So here option C will be the correct answer, that is magnesium hydroxide. Yes, in the case of lemon juice, it is citric acid, right? This is again acid. Then vinegar is acetic acid, right? Then what about the case of last one? If I'm asking about the case of calcium sulfate, whether it is acid, base or salt. So this is a salt formed from calcium hydroxide and sulfuric acid, right? Clear? Any doubt? So from the salt you can identify the parent acid as well as the parent base. I hope you understand. Now we are moving to the third question. So this is our next question. Select a pair of olfactory indicators from the following. Olfactory indicators. So what do you mean by olfactory indicators? What is the main importance of these type of indicators? Okay, Arush is giving me the answer as option A. Yes, option A is the correct answer, that is clove oil and the vanilla essence, right? Olfactory indicators means it is based on the smell of the indicators, right? So clove oil and vanilla essence are the examples of olfactory indicators given here. We have already studied in terms of the different types of indicators there. Okay, parent acid and parent base, right? Okay. For example, if I am taking in the case of calcium sulfate, right? So this is the calcium sulfate. We will be splitting these these salt into two parts, whether it is cation and anion. So what I am doing here, this is Ca2 plus and SO4 2 minus. I am just splitting into two parts, right? Cations and anions. Now we are just adding water molecule here as H plus and OH minus, right? We are adding water in terms of H plus and OH minus. So cation will goes with the OH minus ion and the anion will goes with the H plus ion. So what will be the formula of the base formed here? Ca2 plus, right? Ca2 plus and OH minus. So CaOH twice will be the parent base. Then H2SO4 will be the parent acid. Is that clear? So if you are getting any of the salt, first you need to split into cations and anions. Then cations will go with the OH minus ion and the anions will go with the H plus ion. So based on that you can get the formula of parent base as well as the parent acid. Is there any doubt? So I will give another example. Okay, what will be the parent acid of these salt here, magnesium phosphate? Yes, this is a trick to find out the parent acid as well as parent base. So as we already know, this salt is formed by the neutralization reaction, right? Which means water is removing this, so that I am adding H plus and OH minus here. Is there any doubt? Can you please give me what is the parent acid as well as parent base here in the case of magnesium phosphate? So what we need to do here, I am splitting into cations, right? So it will be Mg2 plus, then it will be PO4 3 minus, right? So what I am doing here, I am adding OH minus with the cation, right? So it will be forming MgOH twice. Then here it will be H3PO4, right? Phosphoric acid. So this is the parent base, this is the parent acid. Is there any doubt? Yes, MgOH twice. Arish, there is a correction in the chemical formula of the magnesium hydroxide. In the case of magnesium, valence is 2. In the case of OH minus or hydroxide ion, valence is 1. Crisscross the valences, you will get the chemical formula as MgOH twice. Clear? Is there any doubt? So these are the parent acid and the parent base for the particular salt given here. Now we are moving to our next question. Okay. So again the question is based on the indicators part. A visually challenged student has to perform a lab test to detect the presence of an acid in a given solution. The acid base indicator preferred by him will be. So these are the examples for the natural indicators. First one is blue litmus, red cabbage extract, clove oil and hibiscus extract. Yes, option C will be the correct answer, right? So these are the examples for the olfactory indicators. If you have any difficulty in the vision, it will be easy to identify by using the olfactory indicators, right? So option C will be the correct answer because this is an olfactory indicator. Now we are moving to our next question. Read the question carefully. Sodium hydroxide is termed as alkali while ferric hydroxide is not because. So what is the answer for this question? First one is the sodium hydroxide, next one is the ferric hydroxide. So there is a simple difference between alkali as well as base, right? Not all the alkalis are bases. So we have already studied in terms of the solubility, right? So what will be the answer for this question? We will be considering the sodium hydroxide as the alkali but not as the base, right? In the case of ferric hydroxide. Okay, Arush, option B is the correct answer here. Sodium hydroxide is a base which is soluble in water. So there will be a small difference between base and alkali. Both of them are, we will be considering as the hydroxide ion, forming hydroxide ion, but in the case of alkali, they will be soluble in water, right? They will be soluble in water. The base that is soluble in water is known as alkali. Is that clear? Is there any doubt? What is the difference between alkali and base? It's almost same, but in terms of our examination point of view, our correct answer is here only because in the case of sodium hydroxide is completely soluble in water because it is easily forming OH minus ion. But in the case of ferric hydroxide, it is not soluble in water. But in the option D, it is almost similar, but the appropriate answer is option B only. I hope you understand. Okay, now we are moving to the next question. When sodium bicarbonate reacts with dilute hydrochloric acid, the gas evolved is. So this is a chemical experiment we have already studied there. Whenever we are treating the sodium bicarbonate with the dilute hydrochloric acid, what is happening there? What is the experimental observation there? Read the options one by one carefully. As we all know which gas is formed there, we need to identify the presence of that gas. Yes, option C is the correct answer, right? Option C is the correct answer. There is an experimental setup already given in our textbook. So many times CBSE is repeating the same question over there. So if you are treating sodium bicarbonate, right? Sodium bicarbonate. So it is forming the sodium bicarbonate NaHCO3, right? It will be treating with HCl to form carbon dioxide plus water, right? Carbon dioxide plus water. So this is the gas formed here. If you are treating with the calcium hydroxide, right, or slaked lime, This is also known as the lime water. So if you are passing this formed carbon dioxide gas with the lime water, this lime water turns milky. So that is the experimental observation happening there. Clear? So option C will be the correct answer. Carbon dioxide turns lime water milky. Is there any doubt? Yes, NaCl is also formed. Salt, carbon dioxide plus water. So if you are taking sodium carbonate also, same experiment is happening here. Now we are moving to, okay, same question. I hope you can see the image clearly here. In the experimental setup given below, it is observed that on passing the gas produced in the reaction in the solution X, the solution X first turns milky and then colorless. Explain the experimental setup. So I hope you can see the image clearly here. This is our, here we are adding our dilute hydrochloric acid and a salt is formed here. There is sodium carbonate is treating with the dilute hydrochloric acid. A particular gas is formed here. Then if you are turning any one of the solution given here, it will be turning milky, right? It will turns milky first, then become colorless. So what is the explanation for this experimental setup? So what is X given here? Yes, carbon dioxide gas is forming here, right? Whenever we are treating the sodium carbonate means Na2CO3. So it will be treating with dilute hydrochloric acid HCl. It will be forming the corresponding salt NaCl. Carbon dioxide plus water, right? So here carbon dioxide gas is formed here. I am taking here as a lime water, right? Lime water or calcium hydroxide. So what is happening here? The carbon dioxide will treat with the calcium hydroxide to form the milky appearance over there. Then after that it will be become colorless because all the carbon dioxide is reacting with the lime water. Is that clear? Yes, Hafsa, you are correct. I hope you understand. So depending upon the marks, you can give the explanation for the experimental setup given here. Maybe it will be 2 or 3 marks question. Okay, can we move to the next question? Yes. So here is the next question. Select from the following the statement which is true for bases. Options are provided here. Bases are bitter and turn blue litmus red. Bases have a pH less than 7 and bases are sour and change red litmus to blue. Bases turn pink when a drop of phenolphthalein is added to them. Yes, option D will be the correct answer, right? So option D will be the correct answer, as we already know. Our first question is based on this question only. I mean, bases turn pink when a drop of phenolphthalein is added to the bases, right? So option D will be the correct answer here. So this is very easy question about the difference between acids and bases. So as we already know. Now we are moving to the next question. An aqueous solution of a salt turns blue litmus to red. The salt could be the one obtained by the reaction of. So this type of question is very important. This is based on the application of the parent acid and parent base. Aqueous solution of a salt turns blue litmus to red. So we need to identify whether it is acid or base. Okay, let's see what is the answer. So option D will be the correct answer here. So what is the role of this salt here, whether it is acidic or basic? Blue litmus to red, whether it is acidic or basic. Yes, option D is the correct answer. So as we already know, they are acidic in nature, right? That's why they are changing the blue litmus to red. So in order to find out the parent acid and parent base, so there is a few more tricks you need to keep in mind. So if the parent acid and parent base are strong, the resulting salt will be neutral. Then if the acid is strong, base is weak, the corresponding salt will be acidic. Next one, if the acid is weak, base is strong, the corresponding salt will be basic, right? Then one more thing is that whenever both acid as well as base is in the weak, they will be having different pKa values, right? We will be discussing later in the case of higher classes. So for your examination point of view, you need to focus these three types only. If you are having strong acid and strong base, you will be getting the neutral salt. If you are having strong acid and weak base, you will be getting the acidic salt. If you are having weak acid and strong base, you will be getting the basic salt. Now you can answer for the question. So here, right, in the case of HCl, this is a strong acid and NH4OH is the weak base, right? So what is our corresponding salt formed here? It will be acidic, right? In the case of option B, H2SO4 is a strong acid, but KOH is a weak base, right? Is that clear? So it will be forming the neutral salt only because both of them are the strong acid and strong base. Now KOH and NaOH are the strong bases. Clear? Okay. Now we are moving to the next question. The latest question asked in the 2024. A few crystals of ferrous sulfate were taken in a dry boiling tube and heated. Tiny water droplets were observed in the tube after some time. First question, from where did these water droplets appear? Explain. Second question is, what color change will be observed during heating? pKa value means there is the strength of acid. There will be, for different acids, there will be having the different pKa value. So depending upon the pKa value, you will be getting an idea about the salt formed is acid, base or neutral. So you will be studying in detail in the case of grade 11, I think. Yes, first question answer will be water of crystallization, right? What is the chemical formula of Fe ferrous sulfate here? What is the water of crystallization here? It will be FeSO4.7H2, right? Water of crystallization is 7 here. So it will be, while heating, it will be removed as the tiny water droplets. So that's why we are experiencing, we are seeing tiny water droplets over there by heating ferrous sulfate crystals. It is ferrous sulfate 7H2O. Now what is the color change observed here? First it will be green color, then it will become colorless. Then after some time, if you are heating again, it will be becoming a brown color of substance. Clear? And two more sub-questions are given here. Write the molecular formula of crystalline forms of copper sulfate and sodium carbonate. So what about the case of copper sulfate? Is there any water of crystallization present or not? Copper sulfate. CuSO4.5H2O, right? Then what about the case of sodium carbonate? Arush, you need to revise the topic once again. Sodium carbonate, Na2CO3, right? Na2CO3 dot 10H2. This is known as our washing soda, right? Okay, fine. Okay, here is the question based on the water of crystallization. After completing the water of crystallization, after completing this question, I will give you the example for the water of crystallization, right? So what is the answer for this question? Select from the following the statement which is true for, okay, there is a correction in the question. We need to identify the formula of plaster of Paris. Forget about the first question. We need to identify the chemical formula for plaster of Paris. Yes, option C is the correct answer, right? CaSO4 dot half H2O. Okay, this is our plaster of Paris, right? This is used for the doctors, ortho doctors. If you have any bone fractures, they will be suggested by using the plaster of Paris over there. And this one is our gypsum, right? Gypsum is used in the hardening of substances, especially in the case of cement work. So this is gypsum, right? Okay. So these are the important salts you need to keep in mind for your examination point of view. These are the salt with the water of crystallization and these are their common names. Clear? Okay, I hope you understand. Now we are moving to the next question. Okay, it's a statement type question. A compound X which is prepared from gypsum has the property of hardening when mixed with proper quantity of water. Identify X and write its chemical formula. Read the question carefully. We need to identify the compound X. When we are treating with the, we will be getting, if you are treating gypsum with water, you will be getting a compound X over here, right? So what is the compound X formed here along with their chemical formula? So what will be our answer? Gypsum is CaSO4.2H2O, right? Is that clear? This is the chemical formula. This one is the gypsum. When gypsum is changes to, okay, whenever gypsum is completed here, it will be forming the corresponding plaster of Paris plus water. Clear? This is the plaster of Paris and this is the gypsum. Remaining will be the water molecule here, 3/2 water molecule, right? So this is the gypsum. Is there any doubt? Okay, now we are moving to the next question. Again, the question is based on the water of crystallization. We need to identify the compound which is having the maximum number of water of crystallization in one molecule. First one is FeSO4, second one copper sulfate, calcium sulfate and Na2CO3. Okay, there is a small correction here. This is not calcium sulfate, this is copper sulfate. Sorry for the correction. Sorry for the mistake. Just note it down. Blue vitriol means copper sulfate dot 5H2O. Okay, now you can answer the question. Which one is having the maximum number of water of crystallization in these molecules? So what will be the answer? Yes, option D will be the correct answer, right? Na2CO3, that is our washing soda. Water of crystallization is equal to 10 here, and for calcium sulfate, it will be either 2H2 or a half H2. If you are taking 2, it will be gypsum. If it is half, it will be plaster of Paris, right? Then CuSO4 means 5H2, blue vitriol. Then FeSO4 is 7 here. So the one which is having the maximum number of water of crystallization in one molecule is sodium carbonate, that is our washing soda. Is that clear? Here is our last question. State the difference between chemical composition of baking powder and baking soda. Read the question carefully. We are asking about the chemical composition of baking powder and baking soda. So what will be the answer? If I am asking about the case of baking soda, what is the chemical formula of baking soda? So this is the question asked in 2023. So we know the difference between baking soda and washing soda, right? So baking soda means it is a sodium bicarbonate, that is NaHCO3, right? Then if you are asking about the case of baking powder, we are just adding a small amount of tartaric acid to the baking soda. You will be getting the corresponding baking powder, right? Especially we are using tartaric acid. So both of them are used for the baking purposes. Clear? Is there any doubt? Is there any doubt? So this was the last question. We have already completed around 15 questions from the acid, base and salt. I am repeating again. This is the composition. We will generally using any of the acid, but generally for the preparation of baking soda, we are using the small amount of tartaric acid. Then only we can get the correct purpose for the baking purposes. Clear, Arush? Okay, fine. So we have already completed the acid, bases and salts. We have already know what are the important physical properties as well as the chemical properties of acid, bases and salts. I'm repeating again, we need to identify the nature of the salt depending upon the parent acid and parent base. So we need time. No, there is no particular composition or particular formula of the baking powder. We can just add like that. We will be adding baking soda to the tartaric acid. We will get the baking powder. That's it. There is no particular formula like baking soda or washing soda in the terms of baking powder. Clear? Okay, there is a gentle reminder about the score examination. As we already know about the score examination, Sri Chaitanya Academy is providing an opportunity for the national level of scholarship examination, which is conducted on September 28 and October 12. So before September 26, you need to register for the examination. The link will be provided in the description. You need to register for the examination. I hope you have already registered for the examination. If anyone missed, just register before September 26. Shashank, we have already completed the chapter. Now we have already taken some of the questions for the PYQs of salts also. Hafsa NaCO3 is the chemical formula of the baking soda, not about the baking powder. If they are asking about the baking powder, you can add like that. We will be mixing baking soda with the tartaric acid. Clear? If you do have any doubt, you can ask. Otherwise, we can wind up the session for today. Okay, no issues, Shashank. Just go with the rewards. We have already completed some of the questions, especially for the preparation of salts. I mean, how we can find out the parent acid and parent base, and how to identify the nature of the salt, like whether it is acid base or neutral, depending upon the strength of acid and base, right? So that's all about from my side for today. I hope you guys enjoyed the session. If you really like the session, hit the like button, share this particular session to your friends also, and subscribe our channel. If you want to get the session PDF, you need to join our Telegram channel. So thank you so much all of you. See you in the next class. Bye bye.